So this is lesson number 67 in Algebra 1, and we're going to start looking at what is called the elimination method. And if you remember back in lesson 54, and if you need to go back there and look at that, that would be fine. When we have two equations like this, we called them systems of equations. And we had something like that. The way we solved this was we were to look at this equation here, and whenever we saw an x, we'd put this in its place. So we would take that and put it in place of x in the top equation and write it like this. Then we would distribute and now, see, all we have is y's. We have one equation with one variable, whereas when we started, we had an x here and a y here, and we can't solve one equation here when we have more than one variable. And we also can't solve more than one equation at a time. So that gave us just our y's. So then we took this one and combined it. Subtracted 22. Now this is old stuff. Divide by -7. Those go away. And y equals 21 over 7, which is 3. And we got our answer. And then we took that 3 and we plugged it into one of these equations up here. Doesn't matter which one, but let's pick the bottom one. And x equals 2. So our answer was 2, 3, because x is 2 and y is 3. Alright, so that's how we did that as far as substitution. One of the things that we need to recognize, and before I erase this, is that our equations aren't always going to look this nice. Sometimes they're going to look really nasty, and we come up with another method to solve those called the elimination method. I can eliminate that. There we go. The elimination method is used when I have problems like x plus 2y equals 8 and 5x minus 2y equals 4. Alright, so notice what we've got here. We have a system of equations where we don't have one of them saying x equals a number or y equals a number. Yeah, we can make this into x equals -2y plus 8 and then take that and substitute. But sometimes that's even harder or more of a pain in the neck than another method called elimination. Alright, what elimination says is, if we draw a line under here and we add these two, let's see what happens. We're going to add the 8 and the 4. You can only add things that are common. We're going to add the 2y and the -2y, which is 0. And we're going to add these two. Okay, so that goes away. Now notice what happened here. One of the variables, the y, disappeared, and all we have is an x, because these turned into zeros when we added them. So now we have 6x equals 12. Divide by 6, divide by 6, x equals 2. See how much faster and easier that was than substituting and saying, okay, x equals -2y equals 8. Now I'm going to take, plus 8. Now I'm going to take -2y plus 8 and substitute it into the bottom one. And sometimes this is easier, but in a lot of cases it's not. And then I keep going and going and going and going and going. Alright, so this way we have over on the left seems to be a lot faster and easier method, and there really wasn't too much to it, was there? All we did was added these two, and these two, and got that right there. Found out our x equals 2. Now we can take either one of our equations, doesn't matter which one, and put the 2 in. So let's take the first one because it looks the simplest. 2 plus 2y equals 8, so I put a 2 in there for x, and that gives me 2y equals 6, divide by 2, y equals 3. So there's my x, and there's my y, and I'm done. Okay, but there's always a big but when we do these, isn't there? There's always some little glitch that we have to work through, and there is in this one, but it's not too bad of one. Let me find an example here. Oh, let's just use this one. 2x minus y equals 13. 3x plus 4y equals 3. Okay, so let's look at this one. What happens when we add these? Let's see. Let's draw our line. Let's put our little thingy here. We get 16. We get 3y. And we get 5x. Notice what happened. We still have two variables. We have one equation and two variables. So that got us absolutely nowhere because we can never figure out the answer to the variables, the x or the y, if there's two of them in one equation. So we have to make a little bit of a change here. So let's get rid of this answer that we have here, if I can. Alright, so what we have to do is we have to figure out a way that one of these, either the x's can go away or the y's can go away, so that when we put our answer down here we only have one variable. So this is the direction that we have to go. We have to choose one of the equations to change a little bit so that the number in front of the x's are the same or the number in front of the y's are the same. Well, it would be real easy for me to make this number a 4. What would I have to do to make this a 4? If I multiply the entire equation by a 4, look what happens. Uh, 52. Alright, so when I did that, when I multiplied the whole thing by 4, including over here on this side of the equal sign, the whole thing, now it becomes a negative 4. Now when I add, what do I get? I get an 11x, even with my lame 8. This turns into 0, and then I can take 52 plus 3 and get 55. Now I divide by 11, and I get 5. Now I take my 5 and I plug it into any one of the equations. Let's take the bottom one. Subtracted 15 from both sides. Divide by 4, and my y equals negative 3. Alright, so that was pretty slick. I was able to find my x and my y without too much trouble. Alright, so that is a trick that you will be getting used to using all the time. Even after you're done with Algebra 1, you'll be using it in other math classes. And let's keep going. Let's look at some other ones here. I think there's just a couple more. 2x minus 3y equals 5. 3x plus 4y equals negative 18. Alright, when you look at these, you'll notice that you can't add these together and get rid of one of the variables. Here you're going to get a 5x, here you're going to get a 1x or a 1y. You can't have that. You've got to have these cancel, which means you're going to have to either make the numbers in front of the x's the same or the numbers in front of the y the same. It does not matter which one you choose. Usually try to choose the easiest one, but it doesn't really matter. Alright, in fact, let's do both of them on this one. Let's do one way and one the other way just to show you. Alright, so notice, I'm going to make the x's the same. This is a 2 and this is a 3. there's no way I can multiply this whole thing by a number to get this to be a 3 or make this into a 2. So what I do is I look for the next best thing. I look for the common multiple. What is the smallest number that 2 goes into and 3 goes into? Well, that's 6. 3 goes into 6 and 2 goes into 6. So if I make those 6's, then that'll be great. So I'm going to multiply this whole top by a 3 to make them all 6's, or to make the x a 6. Okay. Now I'm going to multiply the bottom by a 2, and that's going to give me a 6. Alright, now notice what happens. They're both 6's, but when I add them, they don't cancel because one of them's not a negative. So what I'm going to do is I'm going to multiply this bottom by a negative 2 to make the 3x a negative 6. Then a negative 2 times 4y. Boy, my 8 doesn't look like an 8, does it? And then my negative 2 times negative 18 makes it a positive 36. Now, look what I've got. I can add these two together and they become a 0. I can add these two together and I get negative 17y. And I can add those two together and get 4651. Divide by 17, negative 17. Those go away. My y equals negative 3. Now I take my negative 3 and I plug it into any of these 4 problems up here. It doesn't matter which one of these I plug it into. I just kind of look for the easiest one or whichever one. Let's plug it into this bottom one right here. 3x plus 4 times negative 3 equals negative 18. Add 12. Divide by 3, divide by 3, x equals negative 2. So I found that one, and I found that one. Okay, so I said we're going to do both ways. We just found out how to, what we did first of all is we found x first by making those both 6's. Alright, this next way we're going to do it is we are going to eliminate the y's. So, what is a number that both 3 and 4 go evenly into? The smallest one, and that would be 12. So we want to make this a 12. So how do we make that a 12? We multiply the whole thing by 4, and that makes it into a 12. We get 8x minus 12y equals 20. One of the things a lot of students don't do is they forget to multiply by the 5 to get your 20 there. Don't do that. Okay, we're going to multiply this by a 3. That gives me 9x plus 12y equals 36, 46, 54. Come on. Alright, now we add 17x. Those go away. And 54, 44, 34, negative 34. X equals negative 2. Okay, that should have been the answer we got on the last one. And then we take and plug into whichever problem we want. So see, it doesn't matter which way you go, you're going to end up with the same answer. You just have to decide which one looks the easiest direction to go with. Alright, so let's go ahead and let's see. Okay, that's it for that for A in this lesson in 67, and we'll go ahead and do a real quick video for lesson 67B.